We're going to be talking about absolute max and mins today, okay? And another word for that is extremum, okay? And basically what that means is extreme values. Here we have a graph and we can see that it has two endpoints, and we're going to be using that concept in this lesson, but it has these endpoints. However, we can see the highest point on the graph has a y value of 5, and that point is 1.5, 5. And the smallest point on this graph is -2. That point is -0.5, -2. So this point would be an absolute minimum. This point would be an absolute maximum because this one has the smallest y value. This one has the biggest y value. So that's what an absolute max and min are. Now this leads us to the question, how do we figure those out for a function? Well, you can already see that, you more or less need to know what's happening on the left and right of the graph, okay? So sometimes you have endpoints and sometimes you don't. And furthermore, we can see that the graph changes direction here. They have horizontal tangents. So we're going to be putting together two concepts for absolute min and max: endpoints and critical points. And we're just basically going to put those together to figure out what the absolute maximum and minimum values are on a graph. Let's read the definition. Absolute maximum, the point on the graph of a function that takes on the largest f of x value or y value. Absolute minimum, the point on the graph that takes on the smallest f of x value. Now I want to point out some things before we dive into some examples. There can be multiple absolute maximums. If you look at these y values on this graph, they all have the y value of 1. They share the distinguished privilege of being the highest y value, okay? And if they tie, there can be multiple maximums, okay? Because they all have the highest y value of 1. Same for absolute minimums. These all have the lowest y value of -1. There are no other points that are lower than that, okay? And so that's why they are all the absolute minimum. But how can we figure these points out? Relative max and minimum can only occur at critical points. However, we also have to take into account endpoints, our potential absolute maximum minimum. Why is that? Well, if we look back at our graph, suppose that the graph, if we didn't cut it off at these endpoints, so suppose it went back up, then this wouldn't be the highest point anymore. Same for this one. Suppose this graph, if we didn't cut it off, went back down, then it wouldn't be the lowest point anymore. So endpoints can be absolute max and min. So basically, it's going to occur at either critical points or endpoints, okay? And that's what we're going to do. We're going to figure out critical points and endpoints to solve these examples. So determine the absolute, for example 1, we have determined the absolute extrema for the following function on the interval -1 to 4. So here's our function, f of x equals 3x to the 4th minus 16x cubed plus 18x squared. Now notice we're given this interval, and like we said, the absolute max and min may occur at these two endpoints, but we also need to figure out the critical points because, again, for critical points, that's where the graph can go change direction, and that's where we might have the biggest or smallest values. All right, so for step 1, we're going to determine the endpoints right off the bat. So we're going to be plugging in -1 and 4 into the function to figure out what we get back. When we plug in -1, we get 37. So that is our left endpoint. When we plug in the 4, and I missed a little print. I'll just add it in. Okay. When we plug in 4, we get 32. So our left endpoint is -1, 37. Our right endpoint is 4, 32. That's important because, again, our absolute extrema might occur there. Next, we're going to figure out our critical points. Just a refresher, we have to take the derivative. We're going to be using the power rule here. So f prime of x is 12x cubed minus 48x squared plus 36x. And remember, critical points occur where the derivative equals 0 or it doesn't exist. We can see this is going to exist everywhere because the derivative is a polynomial. So we're just going to figure out where it equals 0. We're going to set it equal to 0. And we can see we can pull a 12x out. We're going to be left with x squared minus 4x plus 3. And we can use the x method to figure out what the factorization for that is. I will show you that real quick. We can see that the top of x is going to be a times c. So it's going to be 3. The bottom is going to be -4. Two numbers that multiply to give you -3 and add to give you -4 are those two. And we can use the shortcut here because the leading coefficient is 1. So it's going to become x minus 3 and x minus 1 for our factorization. Okay? Now when we set each of these factors equal to 0 and solve, we're going to get x equals 0, x equals 3, and x equals 1. So we have 3 critical values. Okay, so to figure out points, we have to plug those back in. So we have to plug in 0, 3, and 1 back into the original. When I plug in 0 back into the original, I get 0 back. So it's my first critical point, 0, 0. When I plug in the critical value of 3 back into the original, I get -27. So 3, -27 is my second critical value, second critical point. And when I plug in 1 back into the original function, I get 5. So my third critical point is 1, 5. So I have these 3 critical points. Now what are we going to do? Well, we figured out our endpoints and our critical points. So we're going to put that on a chart. Okay, I'm going to put all of my endpoints and all of my critical points on the chart. Now, if you notice, the left endpoint is going to be the top row of your chart because it's the smallest value, right? You can't have any critical values that are bigger or smaller than that. Smaller than that. Then we have all of our critical points in between. So I might just label that. They're all critical points. Okay, and then this is my left endpoint, and this is my right endpoint. Okay, so why do we draw a chart? Well, because we have all of our endpoints and critical points on one chart, we can look at these y values and see what's the biggest and what's the smallest, and that will tell us, well, where our absolute max and absolute min are. We can see that this particular point, which is our left endpoint, gives us the biggest y value of 37. It's bigger than all these others, and we can see that at this critical point, 3, -27, it gives us an absolute min because -27 is the smallest of all of my y values. So that's what step 4 is. It's comparing our function values after we do step 3, which is to draw our point chart. So again, a point chart involves all the endpoints and critical points, and then we will compare these function values to figure out what's our absolute max and what's our absolute min. So our absolute max is -137. Our absolute min is 3, -27. Step 5, answer with a reason. This is important. So let's read this together and make sure we give a reason for why these are our critical points. Or sorry, our absolute min and max. Out of all the critical and endpoints, so we are talking about the fact that we compared those two, 3, -27 had the lowest function value. Therefore, it is an absolute minimum. And again, our reason is important because absolute minimum, min and max occur only after we compare our critical and endpoints, and we find, in this case, the smallest y value. So we know it is our absolute minimum. Out of all the critical and endpoints, -137 had the highest function value. Therefore, it is an absolute maximum. So again, we've shown that absolute extreme points can only occur at endpoints at critical points. And so we give that in our reason to be sure that we found both an absolute min and max. Here is our function, and we can see some interesting things. Here is our 2 endpoints. We found some different critical points, but the lowest one was 3, -27. So there we can see it's our lowest y value. The highest point happened to be our endpoint, which was -1, 37. And that was for our original function, 3x to the 4th minus 16x cubed plus 18x squared. All right, that is it for this example. If you have any other questions about absolute max or min, let me know.